The Great Pyramid of Giza holds a silent mathematical code within its stones. This video will reveal the hidden numerical language embedded in ancient monuments around the world. You will discover how structures from Stonehenge to Angkor Wat were designed with a sophisticated understanding of geometry and astronomy that challenges our entire timeline of history. How did cultures separated by oceans and millennia build with the same precise mathematical constants? Why would they encode these complex numbers into their most sacred sites? We are about to uncover a lost science carved in stone, a secret that redefines the intellectual achievements of our ancestors. What does it mean for our understanding of human history if these mathematical blueprints were intentional? A perfect circle and a square are more than just simple shapes. They are the fundamental alphabet of a forgotten language, a code of harmony and proportion that our ancestors saw as the architectural blueprint of the universe itself. This is the world of sacred geometry, a conceptual framework where mathematics and meaning were one and the same. Ancient philosophers, from Plato in Greece to sages in India, spoke of ideal forms, perfect shapes that they believed underpinned all of reality. But this was not just philosophical speculation. Across the globe, from the deserts of Egypt to the jungles of Cambodia, builders were translating these abstract ideas into stone. They were not merely constructing buildings, they were giving physical form to cosmic principles. One of the most profound starting points is a shape known as the Vesica Piscis. Imagine two circles of the same size, overlapping so that the center of each lies on the other's circumference. The almond-shaped space where they intersect is the Vesica Piscis. To ancient geometers, this was the womb of creation, the first day of Genesis, containing within its proportions the mathematical seeds for everything that would follow. From this single act of overlapping circles, you can generate a cascade of other sacred patterns, like the flower of life, a complex web of interlocking circles that symbolizes the interconnectedness of all existence. Why does this matter for understanding a pyramid or a stone circle? Because these patterns and their inherent ratios are the very fingerprints we find encoded in their dimensions. The builders were using a universal language of form, a shared intellectual heritage that whispered the same mathematical secrets regardless of the ocean or millennium that separated them. To comprehend the monuments, we must first learn to read this geometric script, to see the circle and the square not as simple drawings, but as the foundational words of a lost global science. The Great Pyramid of Giza presents a silent stone equation waiting to be solved. Its very shape appears to be a physical representation of a mathematical constant we know as pi, the ratio of a circle's circumference to its diameter. How does a pyramid with its four triangular sides embody a circle? The relationship is ingeniously subtle. If you take the pyramid's height and use it as the radius of an imaginary circle, the circumference of that circle is nearly identical to the perimeter of the pyramid's square base. This is not a rough approximation. It is an alignment of breathtaking precision, suggesting the builders were not just aware of pi, but that they deliberately encoded it into the monument's fundamental blueprint. This geometric riddle is only the beginning. Another profound number appears when you examine the pyramid's face. The slant height, or apothem, from the tip down to the center of a base side, compared to half the length of the base, gives a value that closely mirrors the golden ratio, approximately 1.618. Known as phi, this ratio is celebrated for its unique properties of aesthetic harmony and is found throughout the natural world, from the spiral of a nautilus shell to the arrangement of seeds in a sunflower. Finding it so precisely in the pyramid's proportions strongly implies a deliberate act of mathematical artistry. The sheer scale of this achievement cannot be overstated. We are not looking at small carvings on a tablet, but at a monument composed of millions of limestone blocks, each placed with an accuracy that secures these complex numerical relationships across acres of land. This points to a level of geometric understanding and architectural control that seems to defy the conventional timeline of human knowledge. Why go to such extraordinary lengths to hide these numbers in plain sight? The answer may lie not in the stone itself, but in the stars. These mathematical fingerprints are not confined to the Egyptian desert. Far to the north, on the open expanse of the Salisbury Plain, stands another testament to ancient precision. Stonehenge rises from the earth, a silent circle of sarsen stones that has puzzled observers for centuries. But what if we have been asking the wrong question? It is not merely what Stonehenge was for, but what it was designed to calculate. This monument operates as a Neolithic computer, its very stones acting as fixed components in a complex astronomical machine. The massive heel stone, positioned outside the main circle, is not a random monolith. On the summer solstice, an observer standing within the circle would see the sun rise directly over its peak, a celestial event marked with unwavering accuracy. This is just one alignment in a vast system. The four station stones form a perfect rectangle, and the corners of this rectangle precisely frame the extreme rising and setting points of the moon during its major standstill, a cycle that takes over 18 years to complete. How could a culture without written records track a cycle that spans generations? The answer may lie in the mysterious Aubrey holes, a ring of 56 pits dug just inside the earthwork bank. Researchers suggest these pits were not merely for burial, but formed a primitive counting system. By moving markers from hole to hole in a set pattern, the builders could have predicted lunar eclipses by tracking the passage of years. This implies a sophisticated understanding of arithmetic and celestial mechanics, a working knowledge of the sky's rhythms encoded in earth and stone. The sheer complexity of these interlocking solar and lunar alignments points to a single, stunning conclusion. Stonehenge was not a simple calendar. It was a sophisticated observatory, a predictive instrument carved from Welsh bluestone, demonstrating that the language of sacred geometry was spoken not only in the alignment of pyramids, but in the careful arrangement of standing stones under the open English sky. This discipline is known as archaeoastronomy, a field that bridges the gap between the stones on the ground and the stars in the sky. It asks a fundamental question. How did ancient cultures perceive the cosmos, and how did they embed that cosmic understanding into their most enduring creations? The answer requires more than just an archaeologist's trowel or an astronomer's telescope. It demands a fusion of both, enriched by the study of cultural traditions, to see a site not as a ruin but as a living observatory. Take the magnificent passage tomb of Newgrange in Ireland, older than both Stonehenge and the Great Pyramid. Its entrance is marked by a unique feature called a roof box, a narrow opening carefully positioned above the main doorway. For most of the year, the inner chamber remains in deep darkness. But around the winter solstice, something miraculous occurs. As the sun crests the horizon, a single, narrow beam of light penetrates through this roof box, creeping slowly down the long passageway to illuminate the central chamber for a brief 17 minutes. This is not a chance alignment. It is a precise, engineered event, a moment where the sun itself is invited into a house of the ancestors, symbolizing rebirth and the promise of the returning light. How can we be so sure these alignments are intentional? Modern technology provides the key. Researchers use sophisticated software to digitally rewind the clock, reconstructing the exact positions of the sun, moon, and stars as they would have appeared thousands of years ago. When this celestial map is overlaid onto the architectural plans of an ancient site, the hypotheses can be tested with mathematical rigor. We can move beyond wondering if a certain doorway faces the sunrise and instead calculate the precise day it was designed to capture that first light. This scientific approach transforms speculation into evidence, revealing a pattern of profound celestial observation that spanned the globe. Our ancestors were not just building with stone, they were weaving the very movements of the heavens into the fabric of their world, creating a sacred architecture that connected earth to sky in a language of light and shadow. Across the Atlantic Ocean, another geometric secret lay hidden for centuries within the sprawling ancient metropolis of Teotihuacan. The sheer scale of its ceremonial center, with the massive pyramid of the sun and the elegant pyramid of the moon connected by the grand avenue of the dead, suggests a master plan of immense ambition. But the true genius of its layout is only visible from above, a perspective its builders never had. When you map the positions of its three primary structures, a startling pattern emerges. The pyramid of the sun, the temple of the feathered serpent, and the pyramid of the moon form the 3 points of a perfect right-angled triangle. This is not a rough, approximate shape. The distances between them correspond perfectly to a 3, 4, 5 Pythagorean triple, a cornerstone of geometry. This mathematical relationship defines a triangle with one exact 90-degree angle, a principle formerly credited to the Greek philosopher Pythagoras, who lived centuries after Teotihuacan was at its peak. The consistency is even more profound when you measure these distances in the city's own proposed ancient unit, the Hunab. The ratios hold with an uncanny precision, revealing that this urban design was not an accident of topography, but a deliberate act of mathematical city planning. Why would a civilization encode this specific geometric rule into the very foundation of their city? It speaks to a world where mathematics and cosmology were inseparable. The 3, 4, 5 triangle was likely more than a building tool. It was a sacred form, a representation of cosmic order made manifest on Earth. This finding fundamentally challenges the traditional narrative of mathematical history. It suggests that the deep understanding of geometric principles was not born in one cradle of civilization and then slowly spread to others. Instead, it appears to have been a flame that ignited independently in the minds of brilliant architects separated by vast oceans and millennia. The builders of Teotihuacan were not just stacking stones, they were writing a complex mathematical language onto the landscape itself, a code we are only now beginning to decipher. But the stones themselves speak another universal language, the language of measurement. When Alexander Thom, a brilliant engineer, meticulously surveyed hundreds of ancient stone circles across Britain and France, he stumbled upon a numerical constant that defied simple explanation. Despite the variety in the sizes and shapes of these rings, their dimensions repeatedly pointed to the use of a single, standard unit. He called it the megalithic yard, a length of approximately 2.72 feet. This was not a rough estimate. The consistency he found was statistically overwhelming, suggesting that the builders from Scotland to Brittany were all using the same measuring rod. A similar story unfolds along the Nile. The construction of the Great Pyramid demonstrates an almost obsessive use of the royal cubit, a unit of about 1.72 feet. For a long time, these were seen as separate, regional systems, yet a fascinating question emerges. Could these two units, born an ocean apart, be mathematically linked? Some researchers point to a breathtaking possibility. They suggest that both the megalithic yard and the royal cubit were not arbitrary lengths chosen by a king or a chieftain. Instead, they may have been derived from the dimensions of the Earth itself. Imagine taking the polar circumference of our planet and dividing it in a specific, meaningful way. One proposed theory is that the megalithic yard represents a tiny fraction of this global measurement, a unit born from a grand geodetic survey. The implications of this are staggering. It would mean that these ancient cultures possessed not only a spherical understanding of the Earth, but also the technical capability to measure its size with remarkable accuracy. How could such knowledge be so widespread? The consistency of these units across vast distances hints at a shared, sophisticated system of knowledge. Perhaps it was carried by ancient seafarers navigating forgotten trade routes. Or maybe it points to a common, much older source, a foundational civilization whose mathematical and geographical wisdom was adopted and adapted by cultures we consider separate. The monuments stand as silent witnesses, and the very units used to build them may be the most compelling evidence of all. This same reverence for mathematical harmony echoes from the Acropolis in Athens, where the Parthenon stands as a timeless monument to reason and beauty. Its elegant form is not merely an artistic triumph, it is a carefully calculated equation for visual perfection. Look closely at the temple's facade, at the relationship between its width and height, and you will find the golden ratio. This irrational number, approximately 1.618, appears again and again throughout the structure, governing the spacing of its columns, the proportions of its inner chamber, and the very layout of its foundations. For the ancient Greeks, this was far more than an architectural preference. They called this ratio phi, and they saw it as a divine proportion, a universal constant that represented the ideal balance between parts and the whole. It was a number they observed in the natural world, in the spiral of a seashell and the arrangement of petals on a flower. By embedding phi so deliberately into their most sacred temple, dedicated to the goddess Athena, they were making a profound philosophical statement. They believed the universe itself was constructed according to rational, mathematical laws, and that the highest purpose of human creation was to mirror this cosmic order. The Parthenon is not just a building, it is a physical manifestation of an idea, a belief that truth and beauty are two sides of the same coin, and that both can be expressed through the timeless language of number. This consistent application of a complex, irrational number reveals a level of design sophistication that rivals our modern engineering, all achieved without the aid of digital calculators or computer models. It compels us to ask, how did this specific mathematical knowledge become a shared cornerstone for civilizations that supposedly never met? Could it be that these builders were all drawing from the same deep well of ancient understanding, a universal source code for sacred design that spanned the entire globe? The numbers themselves were often considered sacred. Across ancient India and Southeast Asia, the number 108 appears with a frequency that cannot be accidental. It is found in the rhythmic counts of prayer beads, in the precise angles of temple doorways, and in the staggering number of dancing Shiva statues that once adorned the towers of Angkor Wat. In Dharmic traditions, this number is a complete whole, a symbolic representation of the universe itself, derived from the multiplication of the 12 astrological signs and the 9 planets, or from other profound cosmological equations. It was not merely a count, it was a mantra, a vibration encoded in stone. This symbolic use of numbers was a global phenomenon. The ancient Babylonians, for instance, developed a sophisticated mathematical system based on the number 60. We still live with the legacy of their numerical symbolism every single day, in our 60-minute hours and our 360-degree circles. Their choice was likely not arbitrary, as 60 is a highly divisible number, but it also reflected their complex astronomical observations and their base 60 view of the cosmos. To view these ancient mathematical codes solely as feats of calculation is to miss their deeper purpose. A sequence of numbers in a pyramid's base might be a prayer to the sun god. The geometric layout of a city could be a physical map of the heavens, a terrestrial reflection of a celestial kingdom. The recurring ratios in a temple's design may recount the story of creation, telling the myth of how order emerged from chaos through the language of proportion. When we look at these monuments and see only mathematical constants, we are reading the words but missing the poetry. The numbers were a bridge between the earthly and the divine, a way for a civilization to literally build its cosmology into the landscape, ensuring that their understanding of the universe would endure long after their own time had passed. This cultural context transforms the mystery from a simple "how did they do it" to a much more profound "why did they do it?" The sprawling stone mandala of Angkor Wat is more than a temple. It is a map of the heavens carved into the Cambodian earth. Here, myth and mathematics are fused into a single architectural vision, a sacred machine designed to mirror the cosmos and maintain its delicate balance. Its central tower, a towering lotus bud of sandstone, serves as a colossal gnomon in a solar calendar of breathtaking scale. On the morning of the spring equinox, an observer standing at the western entrance gate would witness the sun rise in perfect alignment directly over this central peak, a moment of celestial harmony engineered into the very axis of the temple. This solar alignment is just the beginning of its astronomical code. The entire layout of the complex, with its long causeways and 5 distinctive towers, is believed to be a terrestrial reflection of the constellation Draco, the dragon, as it would have appeared in the night sky at the time of its construction. This was not a casual resemblance, but a deliberate act of star mapping, bringing a piece of the firmament down to Earth. The mathematical precision deepens even further when we examine the distances between its key structures. Researchers have noted that these measurements correspond with uncanny accuracy to the durations of the 4 yugas, the immense cosmic ages described in Hindu philosophy. These are not years as we count them, but vast cycles of time spanning hundreds of thousands of years, representing the creation, sustenance, and dissolution of the universe. To encode these mythological epochs into physical space required a profound synthesis of astronomy, geometry, and theology. The Khmer architects were not merely building a place of worship, they were constructing a metaphysical engine. They used mathematics as a divine language, a bridge between the world of humans and the realm of the gods. Every proportion, every alignment was a prayer in stone, intended to ensure that the cosmic order, the Dharma, would be preserved through the very structure of their world. Angkor Wat stands as perhaps the ultimate expression of this ancient belief, a universe in miniature where number, star, and spirit become one. Yet a critical question hangs in the air, challenging every alignment and ratio we have uncovered. Are we seeing a deliberate code, or are we simply finding patterns because we are desperately looking for them? This psychological phenomenon, the human tendency to perceive meaningful connections in random data, is a powerful force. Skeptics present a compelling counter-argument. They point out that if you take any large, complex structure and take enough measurements, you will inevitably find some numbers that appear to match known constants, purely by chance. It is a mathematical inevitability, like finding a face in the clouds. This is where the rigor of true investigation must take over. We cannot rely on a single, seemingly perfect number. The evidence must be statistically significant, meaning the probability of it occurring randomly is extraordinarily low. More importantly, it must be supported by archaeological context. Does a proposed geometric pattern hold up if we measure the site using the builder's own original units, like the royal cubit or the megalithic yard, instead of our modern feet or meters? Are there surviving texts, artifacts, or cultural traditions that mention this specific number or ratio, providing a clue that the builders were consciously working with it? For instance, we have Greek texts that explicitly discuss the golden ratio, which strengthens the case for its intentional use in the Parthenon. This healthy, necessary skepticism is not meant to dismiss these wonders, but to refine our search for truth. It forces us to move beyond awe and into a more profound understanding, separating compelling evidence from the seductive lure of coincidence. The real mystery deepens when a pattern withstands this rigorous scrutiny, pointing not to chance but to a mind. Beneath the sun-baked islands of Malta, a different kind of code resonates in absolute darkness. The Hypogeum of Halsaflieni is a labyrinthine sanctuary carved entirely from solid limestone, a subterranean world dating back over 6,000 years. Within its deepest reaches lies the oracle chamber, a room that does not merely hold silence, it transforms sound itself. When a deep, resonant tone is produced within this space, something extraordinary happens. The sound wave does not fade away, it amplifies, vibrating through the very stone with an intensity that can be felt in the bones. This is not a simple echo. It is a standing wave, a precise physical phenomenon where the geometry of the chamber itself acts as a giant acoustic resonator. The frequency that triggers this effect is believed to be around 110 Hz, a specific vibration that modern research suggests can have a profound impact on human brain activity, potentially shifting patterns of thought and perception. The implication is staggering. The builders of this hypogeum may have possessed an intuitive, or perhaps even a calculated, understanding of harmonic resonance. They were not just shaping stone, they were engineering an experience, using the mathematical principles of wavelength and frequency to create a tool for altering consciousness. This acoustic architecture adds a profound new dimension to our understanding of ancient monuments. It moves beyond the visual alignment with stars or the geometric ratios of a pyramid. Here, the hidden code is not seen but heard and felt. It is a sensory key, suggesting that these sacred spaces were designed as multi-sensory interfaces between the physical and the metaphysical. The oracle chamber stands as a testament to a forgotten science of sound, a place where the very walls were tuned like a musical instrument to resonate with the human spirit, guiding it toward realms that silence could never reach. Plato saw the universe as a geometric puzzle, its pieces locked into 5 perfect forms. These are the Platonic solids, shapes so unique that every face is an identical regular polygon. Every corner is exactly the same, and they fit perfectly inside a sphere. He assigned each to a fundamental element. The stable cube was earth, the pointy tetrahedron was fire, the smooth octahedron was air, the multifaceted icosahedron was water, and the mysterious dodecahedron, with its 12 pentagonal faces, was reserved for the stuff of the cosmos itself, the quintessential ether. This was not merely a poetic metaphor. Modern science reveals these same forms in the atomic lattices of crystals and the protein shells of viruses, as if nature itself adheres to this geometric blueprint. So what happens when we search for these cosmic blueprints in the work of ancient builders? The Great Pyramid of Giza, for instance, presents a fascinating case. Its base is a near-perfect square, and its 4 triangular faces can be seen as a physical approximation of 4 of the 8 faces of an octahedron. Could this be a coincidence, or was it an attempt to embody the ideal form of air, of spirit, into a structure meant to launch a soul to the heavens? The connections grow more compelling when we consider sacred spaces designed for contemplation. The geometry of the dodecahedron, Plato's shape for the cosmos, is incredibly complex, yet its underlying pattern, the pentagon, appears in the floor plans of certain Byzantine churches and is fundamental to the proportions of many Islamic shrines. These were not random architectural choices. They were deliberate attempts to build a microcosm, a small piece of the perfect celestial realm here on Earth. This shifts our perception of these ancient engineers. They were not merely stacking stones to create a shelter or a tomb. They were engaged in a profound philosophical act, using hammer and chisel to wrestle perfect, abstract ideas out of the raw chaos of stone. They sought to materialize the ideal, to build a doorway between the imperfect world we inhabit and the flawless, geometric reality they believed underpinned everything. The monuments then become more than buildings. They are philosophical arguments made solid, a silent, stone dialogue about the very nature of reality. High in the Andean clouds, Machu Picchu clings to a mountain ridge, a testament to a civilization that did not simply occupy the land, but conversed with it through mathematics. The city's stonework is its first and most obvious language of precision. Enormous blocks of granite, some weighing many tons, are cut with such exacting angles that they lock together without mortar. For centuries, these walls have held fast, and to this day, you cannot slip a knife blade between the stones. This was more than a display of skill. It was a geometric solution to a violent problem. The Andes are a realm of earthquakes, and the Incas understood that rigid, right-angled structures would shatter under the immense forces of a tremor. Their brilliant answer was the trapezoid. Look at any doorway, window, or niche in Machu Picchu, and you will see this shape repeated. The trapezoid is a dynamic, resilient form. Under stress, it can shift and settle without collapsing, allowing the entire structure to breathe and move with the mountain itself. This was practical geometry of the highest order, a living mathematics built for survival. Yet the city's alignment with its environment extends far beyond seismic stability, reaching directly for the heavens. At the highest point of the sacred complex stands the Intihuatana stone, an intricately carved granite pillar whose name means the hitching post of the sun. This was no crude altar. It functions as a sophisticated astronomical clock and calendar. Its carefully angled planes and precisely positioned corners cast distinct, sharp shadows throughout the year. On the equinoxes, the sun sits directly above the pillar, casting no shadow at all, a moment of perfect celestial balance. During the solstices, the shadows fall in specific, predicted patterns, marking the sun's southernmost and northernmost journeys. The Incas were not just observing the sky, they were tracking time itself, using this stone instrument to anchor their agricultural cycles and ceremonial life to the cosmic rhythm. Machu Picchu, therefore, is not merely a city of stone. It is a three-dimensional equation where architecture, geology, and astronomy merge into a single, intelligent whole, demonstrating a culture that wielded mathematics not as an abstract theory, but as the essential tool for building a world in harmony with the cosmos. This same sequence of numbers whispers its pattern through the very fabric of life. A sunflower's face is not a chaotic spray of seeds, but a masterpiece of mathematical efficiency. Its seeds arrange themselves in opposing spirals, and if you count these spirals, you will almost always find two consecutive Fibonacci numbers, like 34 and 55. This specific arrangement allows for the most seeds to be packed into the smallest space, a perfect design for growth. The same logarithmic spiral, growing wider by a factor of 5 with each quarter turn, shapes the chambered nautilus, each new compartment perfectly proportioned to the last. This is not a random act of biology, but a visible expression of an invisible code, a law of optimal form and function that governs how living things unfold. It was this very pattern that artists and architects began to see and consciously replicate. During the Renaissance, thinkers like Leonardo da Vinci were obsessed with the connection between mathematics, nature, and art. They saw the Fibonacci spiral in the curl of a wave and the curve of a human ear, and they deliberately incorporated these proportions into their work to achieve a sense of natural, inherent beauty. The Great Mosque of Kairouan in Tunisia, one of the oldest places of Islamic learning, reveals this principle in its very foundations. The proportions of its prayer hall and the layout of its courtyard are believed to follow the harmonious ratios derived from this sequence. By doing this, the builders were not just constructing a beautiful space, they were making a profound statement. They were weaving the universal law of organic growth into a man-made structure, creating a sacred environment that felt as naturally ordered and divinely inspired as a forest or a shell. This deliberate mimicry suggests a deep, shared insight across cultures and eras. They understood that the most resonant beauty, whether in a painting, a temple, or a melody, is one that echoes the foundational mathematics of the living world. The built environment, at its most profound, becomes an extension of nature's own logic, a bridge between the wild and the willed, all guided by a simple sequence of numbers first described by an Italian mathematician centuries after these monuments were built. In the coastal state of Odisha, a stone chariot of the gods stands frozen in its eternal journey. The Sun Temple of Konark is not a building in the traditional sense, but a colossal sculpture representing the chariot of the sun god Surya, pulled by 7 mighty horses and rolling on 12 pairs of intricately carved stone wheels. At first glance, this 13th century monument is an overwhelming spectacle of artistic devotion, every surface alive with detailed carvings. But look closer, and you realize that every single element is part of a working machine, a monumental clock designed to measure the passage of the sun itself. Those 12 pairs of wheels are far more than decoration. Each one is a perfectly calibrated sundial. The 8 spokes on every wheel are not uniform, they are carefully angled. As the sun moves across the sky, these spokes cast shadows across the wheel's rim and onto the markers carved between them. These markers are not random decorations either. They indicate precise units of time, allowing an observer to read the hour of the day with astonishing accuracy simply by watching the play of light and shadow across the stone. The sheer scale of this timekeeping system is breathtaking. With 24 individual wheels, the temple grounds are surrounded by a celestial clock face, each wheel contributing to a grand, synchronized display of solar time. But the mathematical genius goes even deeper. The diameters of the wheels themselves are believed to be based on astronomical calculations. Some researchers suggest they correspond to the number of weeks in a year or relate to the complex cycles of the lunar calendar, embedding longer measures of time into the very proportions of the chariot. This is where the line between sacred art and precise science completely dissolves. The artisans and architects of Konark achieved a perfect synthesis. They created a place of profound spiritual significance that is simultaneously a complex scientific instrument. Every beautiful hand-carved detail, from the petals on a wheel to the posture of a horse, serves a dual purpose, celebrating the divine while meticulously tracking its most visible manifestation, the sun. This was functional sacred geometry at its most sublime, a monument that does not just point to the heavens, but actively converses with them, marking the eternal rhythm of days and seasons in silent, perfect stone. The silence of these stones speaks of a profound loss. How could such a sophisticated understanding of the universe, a language of number and stars shared across continents, simply vanish from human memory? The answers are as complex as the codes themselves, pointing to a fragile thread of knowledge easily severed by the tides of history. One of the most poignant symbols of this loss is the Great Library of Alexandria, a repository of ancient wisdom said to have held scrolls from across the known world. Its destruction, a series of fires over centuries, was a catastrophic blow. imagine the countless treatises on geometry, astronomy, and sacred measure that turned to ash, erasing entire schools of thought in the smoke. This was not an isolated event. As vast monotheistic empires rose to power, older pagan traditions and their associated knowledge systems were often systematically suppressed. Temples were repurposed, texts were destroyed, and the intellectual lineages that preserved this esoteric science were broken. The very act of encoding knowledge in stone, meant to make it eternal, also made it silent. Without the living teachers to explain the meaning behind the ratios, the monuments became mute puzzles. This leads to another compelling theory, that the most profound principles were never written down at all. They were part of a strict oral tradition passed in secret from master to initiate over generations. This method preserved purity but created immense vulnerability. If a chain of initiates was broken by conflict, illness, or simply the passing of time, the knowledge died with its last keeper. The grand, unified science of the ancients shattered into fragments, its pieces scattered and diluted. We are left with the haunting realization that human knowledge is not a steady, accumulating climb. It is a story of peaks and valleys, of brilliant light followed by long periods of forgetting. The mathematical codes in these monuments are the artifacts from a lost peak, a golden age of understanding whose full scope we can only glimpse. This raises a humbling question for our own technologically advanced era. What have we, in our turn, forgotten? What core truths about our world and our place in the cosmos might we have misplaced in our rush toward progress, truths that the ancients carved in stone for us to find? The sinuous earthwork known as the Great Serpent Mound uncoils across an Ohio River valley, a quarter-mile-long monument built from soil and stone. This is not a structure you walk inside, but one you witness from above, a form whose meaning is only revealed in its entirety from a vantage point its creators likely never physically possessed. The serpent's open jaws grip a hollow oval shape, often interpreted as an egg, and this precise point is the key to its celestial calendar. On the evening of the summer solstice, the sun sets directly in line with the serpent's head, as if the cosmic egg is being consumed by the setting sun. The body itself, with its 7 distinct coils, is a terrestrial map of the sky. Each major curve aligns with the rising and setting points of the sun at both solstices and equinoxes, marking the extreme boundaries of the sun's annual journey across the horizon. But the true sophistication of this earthwork may lie in a far more subtle and patient rhythm. Some archaeoastronomers suggest that the 3 primary coils are oriented toward the extreme rising points of the moon during its major standstill, an event that occurs only once every 18.6 years. This is a cycle that requires generations of meticulous observation to document and understand. How did the indigenous Adena or Fort ancient cultures who built and maintained this effigy track a celestial event that unfolds over a span longer than a single human lifetime? It speaks to a society that preserved and passed down precise astronomical data through oral tradition for centuries, embedding a long now of lunar knowledge directly into the landscape. The Great Serpent Mound stands as undeniable proof that the drive to encode cosmic order into the earth was a universal human impulse. From the stone computers of Britain to the soil serpents of North America, separated by an entire ocean, different cultures arrived at the same profound conclusion. The heavens above and the earth below were meant to be in a constant, measurable conversation, and humanity's sacred duty was to build the instruments that could listen. Yet these mathematical codes were not confined to stone alone. They were woven into the very stories people told, the great myths that explained the world and humanity's place within it. We often think of mythology as a collection of fanciful tales, but for ancient cultures, these narratives were a sophisticated language, a vessel for preserving profound astronomical and mathematical truths. Take the Egyptian story of Osiris, the god-king who was dismembered and then restored to life. When analyzed not as a simple allegory of death and rebirth, but as a cosmological text, the numbers within the myth align with the grandest clock in the sky, the precession of the equinoxes. This is a slow, 26,000-year wobble in Earth's axis that gradually shifts the position of the stars. The 14 pieces of Osiris's body have been interpreted by some scholars as representing specific periods within this vast cycle, turning a god story into a numerical map of celestial time. A similar depth is found halfway across the world in the Hindu epic of the churning of the ocean of milk. In this vivid tale, gods and demons cooperate to churn the cosmic ocean using a mountain and a great serpent, pulling it back and forth to produce the nectar of immortality. This is far more than a creation story. It is a dynamic allegory for the precessional cycle itself, with the churning motion symbolizing the slow, rhythmic oscillation of the heavens. The specific numbers of gods and demons and the treasures that emerge from the ocean correspond to precise astronomical durations and planetary relationships. Why encode such complex data within a story? Because a myth can survive where a fragile scroll or an oral formula might not. A story passed down through generations becomes a resilient container for knowledge, its symbolic layers protecting the core truth from being lost or corrupted over centuries. The gods and their epic struggles were not just explanations for thunder or the seasons. They were the characters in a grand, celestial drama, and the numbers hidden within their stories were the stage directions, ensuring that the rhythm of the cosmos would never be forgotten. The Pyramid of Kukulkan stands as a silent clockwork of stone, waiting for its moment to awaken. At the ancient Mayan city of Chichen Itza, this step pyramid is not a static monument but a dynamic performance, an architectural event that occurs with the precision of a celestial appointment. On the spring and autumn equinoxes, as the sun sets, a breathtaking spectacle unfolds. The play of light and shadow against the northern staircase creates 7 triangles of brightness that connect to the massive stone serpent heads at the base. This forms the undulating body of the feathered serpent god, Kukulkan, appearing to slither down from the heavens to the earth. This is not a vague resemblance, it is a precisely engineered illusion of light, a phenomenon that demonstrates a profound understanding of solar angles and 3-dimensional geometry. The pyramid itself is a mathematical representation of the Mayan calendar. Each of its 4 sides has 91 steps. When you add these together, you get 364, and the one final step is the shared platform at the summit, bringing the total to 365, the exact number of days in the solar year. This numerical code is woven directly into the structure's physical form, making the calendar a tangible object you can climb. The pyramid's orientation is equally deliberate, aligned to capture these specific solar events with unerring accuracy. It served as a massive communal timekeeping device, synchronizing the rituals of the city with the fundamental rhythm of the cosmos. The Maya saw time not as a linear march, but as a series of sacred, repeating cycles. The descent of the serpent was a moment of powerful confluence, when the boundary between the human world and the divine realm grew thin, a visual confirmation that the cosmic order was in balance. This integration of art, science, and spirituality into a single, breathtaking experience reveals a civilization that did not separate these disciplines, but saw them as interconnected expressions of a single, universal truth. Our modern quest to understand these silent codes is no longer bound by simple tools. We have unlocked a new era of discovery with technologies that peer through stone and see across millennia. Three-dimensional laser scanning captures every contour of a monument, creating a digital twin so precise it can measure deviations smaller than a millimeter. This data reveals subtle curves in pyramid casings and minute angles in stone alignments that were utterly invisible to the human eye for centuries. Ground-penetrating radar sends pulses deep into the earth, mapping buried chambers and hidden foundations without moving a single grain of soil, uncovering the full scale of a site's design. From even higher above, satellite imagery and LiDAR surveys strip away dense jungle canopies to reveal vast, geometric city plans etched into the landscape, patterns impossible to perceive from the ground. We are no longer just looking at these monuments, we are virtually dissecting them. This technological leap is coupled with the power of sophisticated software. Astronomers can now rewind the celestial clock with absolute accuracy, reconstructing the night sky as it appeared over Stonehenge 5,000 years ago to test a solstice alignment beyond any doubt. Statisticians apply rigorous probability models to determine if a recurring number, like the megalithic yard, is a genuine standard or a random cluster of measurements. This hard data acts as a necessary filter, separating compelling evidence from seductive coincidence. It allows us to move beyond speculation and see these structures as their architects intended, not as weathered ruins, but as perfect mathematical models. We are finally reading the blueprint, and with each new scan and simulation, we recover another piece of a lost global science. But every discovery we make comes with a profound responsibility. The very act of investigation can threaten the fragile existence of these ancient sites. As we drill for core samples to date a stone or allow thousands of visitors to walk across sacred ground, we risk causing damage that can never be undone. This creates a deep ethical conflict, a tension between our hunger for knowledge and our duty to protect these irreplaceable treasures for future generations. The question is not just what we can learn, but what we should do. This dilemma extends beyond physical preservation to the very meaning of the knowledge we uncover. For many indigenous communities around the world, these monuments are not abandoned ruins. They are living ancestors, places of deep spiritual significance where cultural memory resides. When outside researchers arrive to study these sites without consultation, it can feel like a continuation of a painful history where their heritage is taken from them and interpreted by others. Who truly owns the past? The answer must be found in collaboration. A new, more respectful approach to archaeology is emerging, one that prioritizes partnership with descendant communities. This means listening to oral histories, respecting ceremonial protocols, and ensuring that the pursuit of academic data does not override spiritual connection. It is about shifting the focus from extraction to conversation, recognizing that the deepest understanding of a place often comes from those whose identity is woven into its stones. Our quest to decipher these mathematical codes must be guided by this principle. We must ensure that our search for answers does not become a modern form of colonization, one that values abstract numbers over living culture. The ultimate goal is a shared stewardship, where science and tradition work together to protect both the physical monument and the profound human story it represents. This is how we honor the builders' legacy, not just by solving their puzzles, but by safeguarding the sacred ground on which they wrote them. High on the arid plains of Peru, an entire desert becomes a canvas for a code of staggering scale. The Nazca lines are not built upward like a pyramid, but drawn outward, immense geoglyphs scratched into the dark surface of the earth to reveal the pale clay beneath. These are designs so vast that their form becomes meaningless from the ground, resolving only into a chaotic network of trenches. Their true identity, that of a sprawling hummingbird, a towering spider, or a winding monkey, is a secret the land keeps until you ascend to the sky. This fundamental fact raises the first great mystery. How, and more importantly why, did a people create magnificent art they could never hope to see? The precision of these figures is breathtaking. The animal forms are not rough sketches but clean, continuous outlines, executed with a geometric clarity that would be challenging on a small sheet of paper, let alone across miles of desert floor. Many of the straight lines are arrow straight for astonishing distances, cutting across the landscape with a laser-like accuracy that seems to defy the natural contours of the land. This was not a haphazard effort. It required an advanced and meticulous system of surveying, a deep understanding of proportion and measurement to transfer a small-scale model onto a colossal, living grid. One compelling theory suggests the entire plateau functions as a giant astronomical calendar. Certain long lines have been found to point directly toward the spot on the horizon where the sun or specific bright stars would rise or set during significant solstices or equinoxes. In this view, the desert becomes a monumental clock face, with the celestial bodies acting as the moving hands. Another interpretation sees the lines as sacred pathways, designed for ritual processions where walking the line was a form of devotional practice, a physical journey mirroring a spiritual one. The animal figures, then, might represent constellations or powerful spiritual guides. The truth may encompass all these ideas. The Nazca lines represent a different kind of mathematical code, one not of complex constants but of immense scale and perfect alignment. It is a code of spatial reasoning, a demonstration that the same mind that could plot the perfect angles of a pyramid could also map a spider across a dozen hillsides. This was not architecture to reach for the heavens, but a colossal diagram drawn upon the earth to invite the sky down, turning a whole landscape into a single, silent, and profoundly enigmatic prayer. This recurring pattern of numbers and shapes presents a profound puzzle for our understanding of human history. Were these mathematical codes carried across oceans by ancient explorers, or did they emerge independently from a shared human mind? One compelling explanation is the universal language hypothesis, the idea that certain geometric and mathematical truths are so deeply woven into the fabric of reality that different cultures could not help but discover them. This is not a modern concept. Philosophers have long spoken of a perennial philosophy, a timeless wisdom that appears across eras and cultures, suggesting that numbers like pi and phi, or principles like the Pythagorean theorem, are not human inventions but fundamental discoveries. They are intrinsic to the universe, waiting to be recognized. Think of it like this: two children born on opposite sides of the world and with no contact will both independently discover that a circle is round. They do not need to be taught this, they experience it directly from the world. In the same way, ancient architects, whether gazing at the pyramids in Egypt or laying out the temples of Mexico, were interacting with the same cosmic blueprint. They observed the same spirals in shells, the same harmonic ratios in music, and the same cyclical patterns in the stars. Their sacred monuments were their way of echoing this universal order, of creating a point of resonance between the human spirit and the mathematical heart of the cosmos. This shared intuition for harmony suggests a deep, perhaps even innate, human connection to these fundamental principles. It implies that the drive to find meaning in number and form is a defining part of who we are. The monuments, then, are not evidence of a single lost civilization, but of a collective awakening, a global flowering of the human mind reaching for the same eternal truths. This perspective transforms the mystery from a question of who taught whom into a far more beautiful possibility. What if these codes are not a secret handed down, but a song that the entire universe is singing, and our ancestors, in their isolated pockets of genius, were all simply learning to hum the same tune. The field of archaeomathematics is only just beginning to find its voice. We stand at the threshold of a new age of discovery, where the questions we can ask are becoming as sophisticated as the monuments themselves. The next wave of breakthroughs will not come from tape measures alone, but from technologies that perceive the world in ways we cannot. Imagine artificial intelligence sifting through millions of satellite images, detecting subtle geometric patterns in ancient city layouts that are invisible to the human eye. These machine learning algorithms could uncover a shared architectural grammar, a fundamental syntax of sacred design that connects sites from every continent. We might discover that the mathematical relationships we have documented are merely the surface layer of a far deeper code, one that operates on a fractal scale, repeating its harmonious proportions from the grand layout of a ceremonial center down to the intricate carvings on a single altar. The very stone of these structures might hold another secret. As our understanding of quantum physics deepens, we may begin to ask if the ancients perceived ratios and resonances at a subatomic level, intuitively building chambers that harmonize with the fundamental vibrations of matter. The long, patient cycles of precession, the great year of the heavens, could be encoded in myth and monument with a precision we are only now equipped to decipher. And then there are the worlds still hidden from us. Beneath the waves, on submerged continental shelves, lie the ruins of coastal settlements drowned at the end of the last ice age. The exploration of these sunken landscapes is the next great frontier. What mathematical blueprints might we find preserved in the silent, watery darkness of a lost city? The coming decade promises to be the most revolutionary period in our study of the ancient world. Each new scan, each algorithmic discovery, each dive into the abyss has the potential to shatter our historical timelines. We are on the verge of realizing that the ancient world was not a collection of isolated cultures, but a tapestry of intellectually advanced societies connected by a shared, numerate understanding of the cosmos. This journey urges us to become literate in a new way, to look upon the past not as a simple sequence of events, but as a complex, beautiful equation waiting to be solved. Our journey from the pyramids to the Andes reveals a world where stone and number are inseparable. These monuments are far more than piles of rock. They are complex repositories of mathematical wisdom, each one a silent library holding volumes of encoded knowledge. We have seen the solar year counted in the steps of a Mayan pyramid and the golden ratio etched into the marble of the Parthenon. We have witnessed celestial cycles tracked in the coils of an earthen serpent and the resonant frequency of a chamber carved deep beneath Malta. This global tapestry of number and form challenges the very idea of a linear human story, one of steady, upward progress. Instead, it suggests a history of brilliant peaks and profound valleys, moments where advanced understanding was achieved, only to be lost to the slow erosion of time, conflict, or forgotten traditions. These silent stones remind us of a profound connection we share with our ancestors. They looked at the same swirling stars, measured the same sunrises, and sought the same fundamental truths about the cosmos and our place within it. They chose to build their answers into the landscape, creating a legacy meant to endure long after their names were forgotten. Let this exploration be a starting point for your own curiosity. Look at the world with new eyes. What other secrets are waiting in plain sight, hidden in the geometry of a local church or the alignment of an ancient road? Share your thoughts and your favorite historical mysteries in the comments below, and subscribe to continue this journey into the unknown.